Hi everybody, welcome back. How's it going? So last time we looked at the idea of the design matrix, and I wrote that down here as basically our table of stuff. So each row of the matrix was, well, you could think about it as a column vector transpose. That's what a row vector is. And our column vector itself, it's just a person. Okay, so it's a bunch of rows of people. All right. And so we can use this because if we do have the n of these things, we have n people, we have n vectors and rows. And so we can calculate all at once our predictions for everybody. Okay, so given some betas, I'm going to ignore the fact about training betas for now, and actually we'll just hover over it very briefly later as to how to do that. But given any beta vector, any parameters, we can calculate all of our associated predictions for those people as a vector. And we're going to write that as y hat, and I might change this notation later because it looks stupid right now, but to explicitly show it's a vector, y hat as a vector is going to be y hat 1 down until y hat n, okay? So that is just saying that it's a column vector, and the first component is the prediction corresponding to the first person, okay? And the nth or the ith thing is for the ith person. That is the prediction we are going to get for that ith person, okay, given their inputs. So we want these things, and so we can actually do this by just writing down x times beta is the mathematical notation for this. And of course, this made no sense to you. X is a matrix, that's our design matrix, and beta is a vector. What I just wrote down is matrix vector multiplication. It's going to make a vector, and we'll see why once we look at what this thing is. So what is x? Well, again, still, it's just x1 transpose, so this is a row vector, where you could think about it as that, and then all the way down until xn transpose, okay? So don't get worried by this, just our rows, our information of stuff. And then we write it like this, where our beta vector is beta naught down until, I'll just write one more so it's clear, beta 1 down until beta, what is the last thing? Well, to make it easier, I said beta was a p-dimensional vector, so this would have to be p minus 1. Sorry about that. This would have to be p minus 1, because then there's p things in that vector. And I know that's kind of irritating, but that's just how the stuff always goes, is, you know, off by 1 kind of weird things. Okay, so this is accurate. What I just wrote down is accurate. Our predictions, this thing would be the ith prediction, because this thing is going to look like this. So what a matrix multiplication does is that, if remember, this is just a row, and this whole thing is a row. That was a terrible arrow sign. So this thing is a column vector. So what matrix multiplication does is it says, okay, I'm actually going to take the transpose of this thing, and I'm going to dot product it with this thing to make the ith component. So what that means is, what I do is, this thing is x1 transpose, and so what that does, if it was a column and then it was a row, then it just turns it back into itself, right? Because it was written as a column, we transpose it, that's what we have right now. That's a row, then you transpose it again, it turns back into a column. So really it's just x1, that's a column, dot your beta vector, okay? So that's the first component, and what type of value is this? This is a number, because remember, dot product is just the element-wise multiplication of these two things, and then you sum up those multiplications, okay? So that thing is a number, and then you do this all the way down, where this thing is xn, again, transpose, so just xn, dot beta, okay? So what that does is, each of these things are the xi, for example, so x1, x2, x3 as vectors, that is the ith person vector, okay? It's the information that we have about the ith person. If we dot product that with our beta vector, we already saw earlier that that's what our prediction is, okay? And so if I could write this explicitly so you could really see it, that's the same thing as doing this. Well, x, the first person's vector, dot beta, well, that's saying beta naught times 1, because the first component of everyone's vector is 1. So beta naught plus beta 1 times x. Now what is the notation here? We're going to make it, this isn't a vector because it's the first person's vector. So this right now as is a vector, except it's going to be the first real component for them, x1. Okay, so this thing itself is a number. It's the first component of that first person's vector. And then we add this all the way up until we get beta p minus 1. So if we have p components in the beta vector, then this thing would be p minus 1 again. And then xp minus 1 as a vector, this is going to be x1 still. Okay, this is all for the first person's vector. All right. And notice that I'm not really writing a vector sign above this one, even though I kind of could. I could write it as beta, and then the sub-0 is specifying that it's the first component of that, but I'm just going to be a little bit sloppy with that and not do that. And so this is beta naught plus, the last thing is for the nth person's vector, so the nth person, well, that's beta naught plus beta 1, and that's still, there's a 1 there that you can't see it. It's plus beta 1. And then x, well, it's the nth person's thing. Okay, so the nth person's vector. And then the first component of that vector, or the first real component, that's not 1. So the second thing. And then plus all the way up until beta p minus 1 times x, again, the nth person's thing, p minus 1. And if you look at what each of these things are, so this, what is this value? Remember, it's a value because we're summing all of these things. This is exactly what the prediction would be for that person. So this, the first thing is the prediction for the first person, which we're going to call y hat. And again, if I was to put a vector here, it doesn't really matter. This itself isn't a vector. This is y hat 1. Okay, it's the first prediction for that person, or it's the only. So now if we look at what each of these things are, this first thing, which is a number, okay, if I'm looking at this whole thing here, this is a number because it's separated by sums, so it adds to one thing, and that thing is exactly the first prediction for that first person, okay? So we used the information for the first person, dot producted that with our parameter vector. That is exactly what it means to have. And I'm just going to write it like this. Instead of adding the vector here, it's just kind of weird, so I'm not going to do that. This thing itself is a number. It's the prediction, a real value, for that first person. And then this is all the way down until I need to move over a little bit. This last thing here, this is going to be the prediction for the nth person, okay? So now that equation we showed is true. We said y hat is equal to x times beta. Y hat, which I'm going to stop putting a vector, it's a vector. Y hat is x times beta, and we showed y right there. Hopefully that made sense. If not, again, don't worry too much about it, but I will see you in the next video. Keep it going.